Hi there, this is a question from the 2016 Exam 2 from the core section. It is question 3bi. So in the start of the question you were given a table there that's got two columns of values. We're given a graph with the r squared value on it as well, and then in the bi part you've been asked to determine the equation of the least squares line that can be used to predict the apparent temperature from the actual temperature, and then to write down the intercept and slope value. So it's in the y equals mx plus c format. That's a linear format. So with this question, I would really recommend that the first thing you ever do if you see a table and then you see a graph is to check what these columns represent. So in this one, apparent temperature here represents this column here, which is in our y equals mx plus c, it's our y column. So if this one here is the y column, then this one must be our x column, and the actual temperature, as you can see, relates to the x-axis. A very common misconception or an incorrect way to answer these questions is people generally just think the first column is your x column and the second column is your y column. And the VCAR exams quite often change these around just to check the students' understandings, that they actually understand that that's not necessarily the x column, that's the x column there. The next thing I want you just to really have a look at is, in all these kind of questions, is to have a look at where the x-axis starts and where the y-axis starts. So in these, it doesn't actually start at 0. The x starts at 20 and the y starts at 16. So if we were to extend these graphs out, so the axis all the way to 0 and then extend it all the way to 0 on the y, we're looking at our point of origin of the Cartesian plane down here. So this does not represent the y-intercept, and obviously, as I said, the origin would be somewhere down here. So be very careful when you're looking at those graphs in the questions. So the best way to answer this question is to use your CAS calculator. So we've got all this data here. Let's pull up the CAS calculator, and we want to use the statistics button. So in the statistics, I've already gone ahead and placed in my two sets of data for this question. So as you can see, I've placed my x column in list 1, and then I've placed my y column in list 2. Your calculator is set up as a standard XY, and I'll show you how you can change that order. So if you realize later after you put the data in, there is a way you can change it, but I like to put the X column first and then the Y column second. Now let's get the linear regression line, calc, regression, linear reg, and this is where you can change. As I said, it's set up as X is the first and Y is the second. If you accidentally put them in the wrong columns and you realize later, you could just go and change it to the appropriate columns. So I'm going to leave it as X is list 1, Y is list 2, and go OK. So using the formula that's been given there, the Y equals A times X plus B, we can look at what the A and the B represent. So in our question down here, we've got it in the y-intercept is by itself at the start. So let's identify which one that was from the calculator, which is the B. So it is negative 1.651115. From the question, as you see, round your answer to two significant figures. So this would be rounded to minus 1.7. So let's place that in there. So minus 1.7. And the value that's with the pronumeral there, we'll have a look, which was the A, which is 0.94265557, and to two significant figures would be 0.94. So let's put in 0.94. And that is the answer. To gain 3 marks, you need to get those two figures. If we have a look at the assessor's comments, this question was done very, very poorly. Only 28% of the cohort managed to get the full 3 marks. And as I said at the start of the video, a lot of these marks, I believe, down here would have come from people just looking at the question, putting the first list in, as their X and the second list as their Y, and hence getting the wrong marks there. So looking back, only 28% of the cohort got the full 3 marks. That says here the first column contained the responsive variable rather than explanatory variable. Students who did not notice this gave their answers as 2.4 and 1.0 in the solutions. So a very simple question, but a little manipulation in the question by changing these two columns caused a lot of students not to pick up on that. So as I said, check that these variables do match the variables on the axes, and you can go from there to work out which column's which. Hopefully this helps.